Hello, my name is Daniel,
I'm Jacob.
I'm Rosalie.
and today we are going to be talking about ocean acidification, a very interesting topic in regards to the health of the ocean. Let us begin. So, what even is ocean acidification? It's as it sounds. Ocean acidification is essentially the oceans becoming more acidic due to the reduction of the pH value of the Earth's oceans, and the worldwide phenomena of oceans becoming more acidic because of interactions with the atmosphere. Application of the carbon dioxide ions into the waters of not just the oceans, but also even lakes, streams, and rivers and whatnot is usually what causes the oceans to become more acidic. And there are a lot of applications to carbon dioxide in the water that can occur, such as the dispersion of fresh water from melting glaciers, abyssal vents expelling carbon dioxide from the deep oceans, and greenhouse gases dissolving into the waters, which the latter of which is probably the most prominent. We'll discuss two of these carbon dioxide transmitters right now. So, two of the most interesting ways that ocean acidification can occur is through the melting of glaciers and hydrothermal events or vents. You would expect glaciers to be carrying a lot of salt water, considering the fact that where you find them are areas where a lot of saltwater creatures reign. However, glaciers contain frozen freshwater, and when they melt, it's bad for the ocean because the freshwater essentially dilutes the seawater and provides it less protection against the carbon dioxide that gets stored into the atmosphere and then to the hydrosphere. Also, due to the fact that freshwater has low alkalinity, this makes the sea more acidic as carbon dioxide goes inside the ocean. Hydrothermal events are also a very interesting case of ocean acidification occurring. As well, hydrothermal vents can provide some sort of protection to animals, such as tube worms, or can even help regulate the chemistry of the ocean, making the deeper waters a bit more habitable for some creatures to live in. At the same time, these vents release some carbon dioxide due to them essentially being volcanic fields of activity sprouting out smoke from the ground. And as carbon dioxide releases out of the vents, it also causes acidification. Next. So, why exactly is it happening? Well, aside from the phenomena I just mentioned, a lot of acidification in the ocean is usually occurring through the anthropogenic or man-made transfer and buildup of carbon dioxide into the oceans via the atmosphere or land. You see, carbon dioxide tends to travel a lot across the world, and usually this traveling is intensified by the burning or any sort of event that expulses carbon dioxide into the air and the atmosphere, such as the burning of fossil fuels or cutting or burning of trees for to create more land. As humans, we do these actions so often because of this. A lot of carbon dioxide is being released into the atmosphere, which thereby makes it present more often in other ecosystems, and essentially makes those ecosystems a lot warmer than they usually do, thereby in the hydrosphere causing acidification. Next. But ocean acidification and worldwide global warming isn't just caused by man-made events. It's also caused naturally by processes such as breathing or the decomposition of deceased organisms. Especially in the case of wildfires burning down trees too, a lot of these processes release carbon into the air, the land, and the ocean. And while one could argue that they aren't as fatal, unlike anthropogenic sources, in the terms that they don't really burn too much carbon dioxide or release it too much into these areas, they can still be just as prominent in inducing ocean acidification. We talked a lot about carbon dioxide releases, so let's talk about the carbon cycle and how it pertains to all this. I'll leave it up to you, Jacob, to talk about the carbon cycle.
All right. Thank you, Daniel. The carbon cycle over the past 200 years has been knocked out of balance amid an unprecedented amount of CO2 entering the atmosphere due to human industrial activity. While the ocean used to be a net source of the world's carbon, meaning that it released more carbon than it took in, it has now become a carbon sink, meaning that it is retaining more of that carbon than it is releasing. And this is due to an increase in industrial activity, an increase of CO2 entering the ocean, which is unprecedented. And as we'll see later on in the presentation, this could have dire consequences, not only for marine life, but also for humans.
So, what is happening? The massive amount of carbon dioxide being absorbed like a sponge by the ocean dissolves in seawater as carbonic acid. And it's literally causing a sea change that is threatening the fundamental chemical balance of ocean and coastal waters from pole to pole. So between 1751 and 2021, the pH value of ocean surface is estimated to have decreased from approximately 8.25 to 8.14. Which doesn't seem like a big difference now, but the massive amount of carbon dioxide being absorbed by the ocean is the carbonic acid. The overload of carbon dioxide in our ocean is causing a sea change, threatening marine life, and in turn, food security, livelihoods, local and global economies. How it affects marine life. It slows the rate at which coral reefs generate calcium carbonate, thus slowing the growth of coral skeletons. Corals are particularly important because they provide homes for many other sea creatures. It is expected to have negative overall effects on many marine species. This could alter marine food chains and food supplies for human. Acidification could also decrease storm protection from reefs, tourism opportunities, and other benefits that are difficult to value. Coral bleaching is becoming weaker due to more acidic and warmer water, removing the helpful algae from their systems. Organisms with calcium carbonate shells, such as sea butterflies and plankton, will be more vulnerable as the acid dissolves in their shells. New predators and prey may be introduced.
So as we've seen earlier, ocean acidification disrupts the carbon cycle, causes global warming, and hurts marine life. But what about its effect on humans? If we look just here at the US, we could see the potentially dire consequences on both our local economies and communities. For example, Alaska's economy relies heavily on its fishing and seafood industry, which employs around 50,000 people and generates an estimated $2 billion in wages per year. But as ocean acidification increasingly negatively impacts the populations of red and blue king crabs in the area, specifically off the Alaskan coast. It poses a threat not only to the crabs themselves, but also the sustainability of the state's economy, which relies heavily on fishing. Not only that, but fishing is a mainstay of the many of the state's rural and tribal communities, and elders are becoming increasingly worried that the increasing ocean acidification and dying off of many species in the area will lead to younger generations breaking those cultural bonds and leaving for better work or more lucrative work. The tourism industry is also being affected in places like Florida, Puerto Rico, and the US Virgin Islands. Just in the Florida Keys alone, the tourism industry generates $4.8 billion per year and employs around 70,000 people. A major draw in the Florida Keys is its coral reefs and its abundant sea life, but as acidification is killing off sea life and bleaching coral reefs, experts are worried that this will cause less people to flock to these areas as a tourist attraction. It's also having effects globally and raising concerns globally. The United Nations recently backed a report calling for the Great Barrier Reef in Australia to be added to the list of World Heritage Sites that are in danger. this could have huge effects for Australia's economy, as it's a major, the Great Coral Reef is a major boon for its economy in terms of tourism, fishing, and its research industries, raking in a total of $4.8 billion annually. Um,
Okay. So what can we do? The ocean has absorbed about 29% of global CO2 emissions since the end of the pre-industrial era. In the last decade, from 2008 to 2017, we've dumped into the atmosphere about 40 gigatons of emissions of heat-trapping gases each year from the burning of fossil fuels and land use change. Or this is the equivalent to 252 million blue whales, which is a lot. So courts are beginning to consider holding fossil fuel producers accountable for damage they knew their producers were causing because they choose to misinform investors and the public about those risks instead of acting to mitigate them. So 5 ways we can help save our oceans is 1, reduce your carbon footprint. The main cause of this is from increasing amounts of carbon dioxide entering the ocean. 2, stay away from plastic. 3, keep our beaches clean. 4, use sustainable seafood choices. 5, educate yourself and others.
And that concludes our presentation, and here are our sources. Thank you for listening.